Hello, and welcome to this FMSP online revision session. This session is looking at the MEI Statistics 1 specification and the topic of processes and data presentation. We'll start by looking at the specification and seeing what you need to know. There are a lot of objectives for this section, but a lot of it is background knowledge. These first objectives are fairly general. They are just background knowledge and they won't be specifically assessed. Then there's several points that actually are really assumed knowledge from GCSE. There might be the odd mark in a question for these as part of another question. And then we get on to the new ideas. This is what the exam will focus on. A vertical line chart, that's just a bar chart with lines instead of bars, and it's used for probability. You need to be confident with histograms, and we will look at that in some detail. Cumulative frequency, you should know that from GCSE, but that seems to be considered to be something that will be focused on, and again we'll have a look at that in some detail. You need to know the definitions of skewness. You need to know about mid-range, and people forget this one because it's so simple, but it's not one that you met before. It's the highest value plus the lowest value divided by 2, in other words the average halfway point between the highest and lowest values. Know the usefulness of each of the above measures of central tendency, so mid-range and the mean, median and mode, which you know and love. Then you need to know about percentiles. Those are just like quartiles, but instead of dividing the data into 4 parts, you divide them into 100. Now, these ones, mean squared deviation, root mean squared deviation, variance, and standard deviation. These are not in the formula book, so you need to learn the formula. It's useful to be able to use the statistical functions of a calculator. You can do it without, but it is well worth spending a bit of time checking those out. You need to know about linear coding, and I'll look at that briefly, and the term outlier and the fact that there are 2 different ways of defining an outlier, and we'll look at both of those and how you can try not to get them confused. So, some key points that you need to remember. Box plots, I don't think you'll be asked to draw one, but you do need to be confident in interpreting them. And you might be asked about outliers. So here's our first definition. When you are working with the median and interquartile range and quartiles, then outliers are 1.5 times the interquartile range, above or below, not the median, but the upper or lower quartiles. You need to be able to draw a stem and leaf diagram. The most common mistake here is forgetting to draw the key. And histograms, all you really need to remember is that the area of the bar is what represents the frequency. Then we've got skew. Positive skew data mostly on the left, so it looks like that. And negative skew data mostly on the right, so it looks like that. Now, you've been finding the mean from group data probably since you were in year 7, but it is amazing how many people manage to get it wrong by not thinking about what they're doing. Do always check that your mean looks reasonable. And make sure you have learnt that definition of mid-range. It would be a shame to lose a mark for something as simple as mid-range. You need to be able to do interpolation. So that means identifying the class in which the required item lies, and then using a proportionality argument to work out how far along the class it lies. Here's the formula for variance that you need to learn. Do work out how to do it on your calculator, but make sure you've got the right one. Most calculators will have 2. They'll have the population standard deviation, so they will give you the square rooted value, not the variance. It's usually standard deviation that they give you. And the sample standard deviation. And when this specification talks about variance and standard deviation, they're talking about sample variance and sample standard deviation. So make sure that you pick the right one from your calculator, and well before the exam, check out which one gives you the answer that you're after, and remember. Outliers. I said there were two definitions of outliers, and you need to make sure you use the correct one. If you're working with the mean and standard deviation, it's 2 standard deviations above or below the mean. Whereas with median and quartiles, it's 1.5 times the interquartile range, and you're measuring not above the median, but above the upper quartile or below the lower quartile. Very easy to mix those up, so make sure you spend some time getting that clear in your head. Then we've got linear coding. If you multiply every item of data by something and add the same thing to each one, then you do exactly the same to the mean. But with the standard deviation, you do the multiplier, which will affect how spread out the data is, but you don't add B, because simply shifting all the data up by the same amount doesn't affect the spread. Okay, those are the key points, but it'll be useful to look at a number of exam questions to look at some of these in more detail. It's always a good idea to read through the whole question first and highlight any key points. So we've got speeds in miles per hour, 15 vehicles. They want a sorted stem and leaf diagram, and you're given the stem values, so you must use the ones they say. Then write down the median and mid-range, and then decide which one you want, and don't forget to explain to make sure you get all the marks. So, a sorted stem and leaf diagram, I think the easiest way of doing this is actually to do an unsorted one first. It involves more writing down, but you can do it so much more quickly that I think in the end it's quicker and is more likely to result in the correct answer. So what you do, you've got your stem, and then you just go through each one in turn. 73, 67, 75, 64, 52, 63, 75, 81, 77, 72, 68, 74, 79, 72 and 71. And if you're doing that, you'll have one hand on the numbers and one hand writing. You'll be able to do it twice as fast as I did when I was underlining each one to show you what I was doing. For your working, you don't need to worry about things being evenly spaced either. That's just your working. And then we're going to do our sorted one. 5, 6, 7, 8, 52. You can just read off the 6 ones. 3, 4, 7, 8. And then taking care with the 7s. There's a 1. There are 2 2s. A 3. A 4. And then you can probably just read the rest off. 5, 5, 7, 9. Making sure they're evenly spaced. And remembering to put a key at the bottom. 5, 2 represents 52 miles per hour. And then put a line through the one that you don't want them to mark. Write down the median. Well, we had 15 items of data, so we want the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. It's that one there. So the median is 72 miles an hour. The mid-range is the lowest value plus the highest value divided by 2, which is 66.5 miles per hour. And which one would you use? Well, a suitable answer would be to say the median, as most of the data is in the top half of the range. if you look at 66.5 on our stem and leaf diagram, it's way down towards the bottom. So the mid-range is not representative. Alternatively, you could have commented on the fact that 52 is very much an outlier. We haven't done any calculations on that, but you can see it's a long way below all the rest of the data. Okay, let's see how the mark scheme works for this question. For the stem and leaf diagram, there is 1 mark for the stem, 1 mark for the leaves, 1 mark for them being sorted, and 1 mark for the key. For part 2, it's just a straightforward 1 mark for each, and your median is follow through your diagram. So if you made a mistake on the diagram, then they'll follow through for that. And for part 3, there's 1 mark for saying median and 1 mark for an explanation which refers either to the lack of symmetry of the distribution or to the outlier. Okay, let's move on to histograms. This is question 1 from a paper, so a reasonably straightforward starting point, reading a histogram rather than drawing one. We've got a number of sections of a race on cobbled road. The lengths of these sections are illustrated in the histogram measured in metres. So find the number of sections, that's frequency, between 1000 and 2000, so that's going to be that bar there. Name the type of skewness and state the minimum and maximum possible values of the mid-range, because of course we've got group data here, so we don't know exactly what the data is. So for part 1 I need area A, which is 1000 times 0.013, which is 13, so there are 13 sections. The data is skewed to the left, so that's positive skew. And the mid-range, well, we're going to get a minimum value of the mid-range if everything's as low as possible. So in this first block there might be a value of 0, or as close to 0 as makes no difference. And in this top block the highest value might actually only be 3000. So that will give us our minimum value, and our maximum value would be if actually the lowest value was barely below the 1000 and the maximum value was right up there at 4000. Oh, sorry, adding them up instead of dividing by 2. 5000 divided by 2, 2500. Okay, the mark scheme for this question is equally straightforward. There's a method mark for that multiplication, an accuracy mark for getting it correct, and then simply 1 mark with no consideration of your working for each of the other parts. Okay, a much longer question here from later in the paper on cumulative frequency. So the heating quality of the coal in a sample, 50 sacks, measured in suitable units, which they don't tell you. We've got our data there. We've got a cumulative frequency diagram to draw. It says use the diagram to estimate the median and interquartile range, so we can't do interpolation. It has to be done from the diagram. Show that with enough working there are no outliers in the sample. And then we've got a couple of probability questions at the end. Okay, so the first thing we need to do is to work out those cumulative frequency values. So 5 and 7 is 12, and 15 is 27, and 16 is 43, and 7 is 50. We'll then label our axes 9.0, 9.2, 9.4, 9.6, 9.8, 10.0 and 10.2, and up the side 10, 20, 30, 40, 50. And this, you must label everything. That's cumulative frequency, and this is heating quality, whatever that means. Okay, now we know that there are no values below 9.1, so we can mark that. By the time we reach 9.3, we've hit 5. By the time we reach 9.5, we've hit 12. By the time we reach 9.7, we've reached 27. At 9.9, we've reached 43. I make no promises for the accuracy of doing this on the screen. And 10.1 is 50. You then join those up with a smooth curve, which again will be much easier to do on paper. Okay, there's my cumulative frequency diagram. Use the diagram to estimate the median and interquartile range of the data. So we've got 50 items, so we draw in a dotted line across here and read off a value there at the bottom. For the lower quartile, reading off at 12.5, and the upper quartile reading off at 37.5. And you really can't get a decent reading of this on the screen. So if you want to actually try this question yourself, the values that you should get are for the median 9.68, for the lower quartile 9.51, for the upper quartile 9.83, and that then gives us for the interquartile range 9.83 minus 9.51, which is 0.32. And for the lack of outliers, it's interquartile range, so that was 1.5 times the interquartile range. 1.5 times 0.32 is 0.48. And remember that we add that to the upper quartile to give 10.31, and subtract it from the lower quartile to give 9.03. And they are outliers if above 10.31 or below 9.03. So there are no outliers in the sample. And then on to the probability questions. So we've got 3 sacks selected at random. Probability that all 3 are more than 9.5. So let's go back and have a look. So above 9.5, 15, 16 and 7 is 38. So we have 38 sacks out of 50. So 38 out of 50, the probability that the first one is more than 9.5. We've taken one, so there are 37 left out of 49, and then 36 left out of 48. And that comes to 0.4304. For part B, we want the probability that at least 2 are more than 9.5. So, at least 2 means, well, the first one could be, and then the second one we've only got 37 left, and then the third one wouldn't be, so there are 12 that aren't out of the 48 remaining. Now there are 3 different ways of doing it, and although each individual probability will be different, the total will be the same, so we can just multiply that by 3, and then of course add on the 0.4304 that we worked out in part A, and that comes to actually 0.4304 plus 0.4304, which is 0.861. Okay, let's have a look and see how the mark scheme works for this question. For the graph, there is 1 mark for the scales. There is 1 mark for them being labelled. So these very basic things are worth marks. There's 1 mark for plotting the points and 1 mark for your line joining them. And all of those are dependent on an attempt at cumulative frequency. So if you haven't done cumulative frequency, you won't get anything. But if you've got if you made some arithmetic errors there, then you'd probably get everything apart from the one for the points. For part 2, there's just 1 mark here, which is follow through your graph. There's 1 mark for one of the lower quartile or upper quartile. And then another mark for getting the interquartile range, and that is dependent on that one being correct. Okay, for the outliers there's simply 1 mark for that with follow through again, 1 mark for this one with follow through again, and an explanation mark there, which is dependent on getting both of those values correct for your reading of the graph. For part 4, there is 1 method mark for getting 38/50ths multiplied by 2 other probabilities, and then there's another mark for those 2 probabilities being correct, and an accuracy mark for getting that absolutely right. And for part B, there's a method mark for 3 correct fractions. There's a method mark for multiplying something that looks vaguely sensible by 3, or by having 3 reasonably sensible looking triples. There's a method mark independent of all that for adding on your answer from the previous question with follow through allowed for that method mark. But to get the final accuracy mark, you've actually got to get the correct answer. Okay, and to finish off, we've got a question on histograms and standard deviation. So we've got incomes, income in thousands of pounds with frequencies. We've got to draw a histogram. We've got to calculate an estimate of the mean, because it's group data, so we can't do anything else, and then an estimate of the standard deviation. Then it says use your answers to parts 2 and 3. So you've got to use that method to show that there are almost certainly some outliers, and then explain whether or not it will be appropriate to exclude those from the calculation. 4 marks here, and there's a number of things to do, and it's really important that you don't miss any of those out. And then there's a little bit of linear coding. Okay, so drawing the histogram. Well, the 2 things you need to add to your table are class width, so that's 20, 20, 20, 40 and 100. And then you need the frequency density, which is your frequency divided by the class width. So 238 divided by 20 is 11.9. 365 divided by 20 is 18.25. 142 divided by 20 is 7.1. 128 divided by 40 is 3.2. And 45 divided by 100, 0.45. You then need to label up your graph. And you need to label that as frequency density. And along here, I've got an awful lot of space, but I'm going to make that 40, 80, 120, 160, 200. Oh, no, I missed out 180. That's looking at the values that we've been given. So, oh no, I haven't, because I'm going up in 40s. So that was right. Right, but my bars are not going to be as wide, all as wide as that. So the first bar is only 20 wide, and this is going to be terribly wobbly, up to 11.9. So this is just giving you an idea. And then the next one up to 18.25, up to 40. Next one, 7.1. That's 6, so 7 will be back there. And then 3.2, and that goes from 60 all the way up to 100. And then 0.45 right down here all the way to 200. Do use a ruler for yours. Okay, then calculate an estimate of the mean income. Well, you need to take the midpoints of each of the intervals, so 10, 30, 50, 80 and 150. And then to find the mean, you need 10 times 238 plus 330 times 365 plus 50 times 142. Then there are 128 with a nominal value of 80 and 45 with a nominal value of 150. And we divide that by the total, which is 918. So this is the mean, and that comes out to be 37420 over 918, which is 40.8. Then for part 3, the standard deviation is, well, actually I'm not going to work that out on this line. I'm going to do my squared sum first. So 10 squared times 238, I'm going to do this as a separate calculation, plus 30 squared times 365, plus 50 squared times 142, plus 80 squared times 128, plus 150 squared times 45. And that comes out to be 2539,000. Okay, then our standard deviation is the square root of 2,539,000. Take away the mean, and note that I'm putting in the accurate value of this, 37,420 over 918. So the total squared divided by 918, and then divide that by 917, n minus 1. So 1013666 all over 917 square rooted, and that's 33.2. Then it says use your answers to parts 2 and 3 to show there are almost certainly some outliers. So this is the other definition of outliers. So you take the mean and you subtract 2 lots of the standard deviation. So the mean was 40.8, and you take off 2 times 33.2, and that's minus 25.6. And then you take the mean and add 2 standard deviations, so 40.8 plus 2 lots of 33.2, and that is 107.2. Now, the first one's negative, so that's no good, but we've got a category of 100 to 200, and it's highly likely that one of those will be above 107.2, so that's what they're after here. So, almost certainly some values in the 100 to 200 class are above 107.2. They should not be excluded because there's nothing to suggest they are rogue bits of data. There's nothing to suggest that they come from a different population. They're perfectly valid and need to be included. So in general, outliers are things that you need to take a second look at rather than just say, oh no, it's an outlier, so we're going to ignore it. It's worth taking a second look at to make sure it's not a mistake or a rogue value, but if you've got no evidence to suggest that it is, then they should be included. And finally, a little bit of linear coding. The new mean is going to be 1.15 times the accurate value of the old one, not my rounded value, which is 46.88, and the new variance now the variance was 1013666 over 917 before we square rooted it. So that's 1013666 over 917, and this is the variance, not the standard deviation. You multiply the standard deviation by 1.15, but the variance is that squared, so we need to square the 1.15, and that comes to 1462. Okay, let's look at the mark scheme for this long question. Okay, for your nicely ruler drawn histogram, there is 1 mark for the scale and labels. There is 1 mark for the also on the vertical axis. There is 1 mark for the scale and the width of the bars on the horizontal axis, and there is 1 mark for the heights being correct. There are also a method mark and an accuracy mark for doing those calculations of the heights to start with. So those are your 5 marks. For part 2, for the mean income, there's a method mark for that calculation there and an accuracy mark for 40.8. For the standard deviation, there's a method mark for at least 3 terms in this calculation and an accuracy mark. There's then a method mark for substituting in what you've had into that formula and an accuracy mark for the correct answer of 33.2. For part 4, there's a method mark for either one of those, and an accuracy mark for this one, which is the one that you actually need. There's an explanation mark for a suitable comment about why there's almost certainly some outliers, and an explanation mark on for saying they shouldn't be excluded, and that is dependent on this being reasonably accurate. They say between 106 and 108. And finally, for the linear coding, there's just a single mark for the new mean, and it's follow through from whatever you've got. And for the new variance, a method mark and an accuracy mark, and again it's follow through provided that you've got a value that was greater than 0. Well, that's all you need to know about data presentation and processes for MEI Stats 1. I look forward to your company in the rest of the MEI S1 videos and wish you all the best with your exams.